Hey everybody, this is Introduction to Section 1.1, which is a review of functions. You can go log on to WebAssign and look at the ebook already if you have access. If you don't have access, then you can view this video. So a function is a rule that assigns to each value in the domain a unique value in the range. And so what we're going to do, we're going to look at bit of some function machines. So for example, if I have a function machine, you may have seen these in pre-calc. So if I had 1 and 2 in here and something in the range, say 2, 3, and 7, so the rule will be 1 goes to 2, 2 goes to 3, and say 2 also goes to 7. So the question is this a function or not? What do you think? So to remind ourselves, a function is a rule that assigns to each value in the domain a unique value in the range. So this will be the domain where the input originates, and this will be the range. So does each value in the domain have a unique value in the range? And the answer is no, right? This is not a function because 2 goes to 2 different places, so it doesn't go to a unique place. Now say I have a different one that is 2, 4, 6. So this is my domain, and the range say is 3, 5, 7, and let's say 2 goes to 3, and we will say that 4 goes to 5, but 6 also goes to 5. So is this a function or no? And in this case, so the question is, does everything in the domain goes directly to exactly one value in the range? And yes, this goes to each single item in the domain goes to one value in the range. The 2 domain values go to a single one, but that's okay. So the domain here will be 2, 4, 6, and the range here is only 3 and 5. 7 is not being used. Notice that. That's why I didn't call this necessarily the range. These are the inputs and these are the outputs, but the range is really the outputs that are used. So only 3 and 5. In a graph, this will be similar to something that's not a function. We can think of examples of things that are not functions. So like a sideways parabola, because value in the domain goes to not a unique value in the range. Things like circles, right? A value in the domain does not go to a unique value in the range. So these are things that are not functions. Things that will be a function will be things like lines. So the case that's happening here, where different domain values go to the same output, will be like our y equals x squared. So if you look at, for example, 4, that's a range value, and 4 comes from -2, but it also comes from 2. So having range value repeated, it's okay, but you cannot repeat a domain value. So this one will be a domain value gets repeated, whereas this one, the range value gets repeated, and that's okay. That's a function is every input has exactly one output. And so perfect example of something that every domain has an output and the output is the same will be a horizontal line. So if I graph the line y equals 5, for example, that's a horizontal line at y equals 5. But this is a function. Every place in the domain goes to exactly one output. it's the same output, but everything in the domain goes to one output. And this is where the passing the vertical line test comes from, that we say if it passes the vertical line test, then it's a function. Vertical line test means if you were to draw a vertical line anywhere on the graph, it will touch only once. So parabola, yes. Vertical line, a line there, yes. Here, no, right? If you draw a vertical line, then you get 2 spots. Circle, if you draw a vertical line, you get 2 spots. So those are not functions. Now when you have an expression, how do you find the domain of a function? So let me go back over here. So in this example, use the vertical line test to identify graphs in which y is a function of x. And as you can see, A, yes, this will be a function. B, no. Right? If you draw a vertical line on top of the vertical line, that's not going to work. C, is it a function or not a function? So you can use the vertical line test. If you draw a line through that, you're going to touch multiple times. So not a function. And D, same thing. It's not a function. If you draw a vertical line, it touches more than once. So that makes it not a function. The domain is the x values for which a function is defined. So we're going to try this example. Find the domain of this function and write it in interval notation. So take a moment, write it down, and think about what that will look like. And if you want, you can start with finding the values first, and then, but usually we want to start with the domain. So let's go back over here. So the domain of that function, it was f of x equals the square root of x minus 1. Now, what's something you know about square roots? You can't take the square root of a negative number, right? So this means x minus 1 cannot be a negative number. Cannot be less than 0. So that means negative number. So that means that we want, I feel like my hand keeps getting in the way. So we want the quantity x minus 1 then to be greater than or equal to 0, because we can only take the square root of positive numbers and of 0, right? The square root of 0 is 0. The square root of 1 is 1, and so on. But you can't take the square root of a negative number. This is not a real number. So the domain is x minus 1 has to be greater than or equal to 0, so that means we want x to be greater or equal to 1. So that's our domain. In interval notation, some of you may want a number line, so there's 1. That's greater or equal to means it's included, and then you shade everything to the right, everything that is greater than 1. So then in interval notation, this will be from 1 all the way to infinity. You don't have to do the number line. If you can go from there to there, then that is fine. But some of us who are visual may want the number line as an intermediate step. So some of the other things I was asking you to find was to find f of 5. So first thing is 5 in the domain? Yes, right, between 1 and infinity, 5 is in there, so I can definitely find it. So it would be the square root of 5 minus 1, which is the square root of 4, which is 2. And we can do the same for the other ones. F of 17, is 17 in the domain? Yes, 17 is a number between 1 and infinity, so I can plug that in. Right, if I had asked you for f of negative 3, now we have a problem because I can't just plug it in. You're going to get not a real number, but notice that negative 3, so the first thing you got to ask yourself is this number in the domain? Negative 3 is not in 1 to infinity, so I don't need to worry about it. I will say this is not defined or not a real number. Or you can just say negative 3 is not in the domain. So that's why it's important to find the domain of a function first, because then as we're asked for other numbers, for other values, then we know, is it in the domain? Yes, okay, I can find it. No, it's not in the domain. I don't need to go any further. Now for things that are obscure, like f of a plus b, I don't know why a and b are, so we're just gonna find them. So this will be, everywhere you see an x, you replace it with a plus b. So this will be a plus b minus 1. And the last one was f of x plus h. And from pre-calculus, you may have done lots of difference quotient. So, but again, same thing, everywhere you see an x, you replace it with the quantity in here. Notice that our function was f of x equals the square root of x minus 1. So when we found f of 5, what did we do? We solved the x with a 5. When we found f of 17, we replaced this x with the 17. When we found f of a plus b, we replaced the x with a plus b. So when we're finding f of x plus h, this whole thing in the parentheses takes the place of x. So this is going to look like x plus h minus 1. We don't really need the parentheses there, so it's just x plus h minus 1. Right, be careful. The thing you don't want to say is that this is the square root of x minus 1 plus h. That is not what this is. What this will be f of x plus h. You're adding the h on the outside, but that's not what we're doing. We're adding the h on the inside. We're adding it to the domain. Okay, now on your own, I want you to try this problem. So find the domain of f of x equals 3 over x squared minus 9 and express the domain in set builder notation and in interval notation. And then find those values, f of 0, 4, negative 1, and f of x plus h. And we will start with this problem in class. And I will record a second video to talk about piecewise functions.